Section 2.11, Divisibility and Multiples of Numbers. The number a is divisible by the number b if a divided by b has no remainder. Example, is 10 divisible by 2? In order to answer this question, we need to go back to the definition and see how the numbers fit. The number 10 is divisible by the number 2 if 10 divided by 2 has no remainder. 10 divided by 2. What's 10 divided by 2? 10 divided by 2 is 5. There's no remainder. So yes, 10 is divisible by 2. Example, is 8 divisible by 16? We'll use the definition again. 8 is divisible by 16 if 8 divided by 16 has no remainder. What's 8 divided by 16? A lot of students' reflex is to say 8 divided by 16 is 2, but that's not correct. 8 divided by 16 is going to leave you with 8 over 16. If you have 8 objects and you're trying to make groups of 16, you will have leftover pieces. You have 0 complete groups and 8 pieces left over. So no, 8 is not divisible by 16. Getting the order right of these calculations is extremely important. There are also a number of tricks for recognizing divisibility, but these aren't essential to know. For example, you may be familiar with the fact that if a number ends in 0 or 5, then 5 will go into it evenly. Or if the last digit is even, then 2 will go into it evenly. The multiples of the number a are the numbers you get when you add a to itself multiple times. Example, write the first 10 multiples of 7. So we start with 7, and we add 7 to itself. 7 plus 7 is 14. And we add 7 again. 14 plus 7 is 21. And then 28, 35, 42, 49, 56, 63, 70. The least common multiple of two numbers is the smallest positive number that is a multiple of both of the numbers. Example, find the least common multiple of 5 and 7. In order to find the least common multiple of 5 and 7, we have to think about the multiples of 5 and the multiples of 7. So multiples of 5 look like 5, 10, 15, 20, 25. Multiples of 7 look like 7, 14, 21, 28, 35, and so on. We don't have any matches yet, so we're going to keep on extending these lists, 30, 35, until we find something that is in both lists. And this is the smallest number, making it the least common multiple of 5 and 7. The LCM, least common multiple of 5 and 7, is 35. Eventually, you will get to the point where you can do this calculation without having to write out the individual multiples. But for now, you should take the time to do it to practice and get used to these numbers. Section 2.12, Factoring Numbers. To factor a number means to write it as a product of numbers. Example, find all the factorizations of the number 20 as a product of two numbers. 20 equals. We have to come up with pairs of numbers that multiply together to give us 20. There's always an easy example, which is 1 times itself. There's also 2 times 10, and there's 4 times 5. It's important to do this process systematically because otherwise it's possible to skip numbers without realizing it. A composite number is a number that can be factored further. A prime number is a number that cannot be factored further. So for example, the number 20 is a composite number because it can be broken down further, but the number 2 is prime because it cannot. 2 can only be written as 2 times 1. Example, completely factor 24. To completely factor a number means to write it as a product of primes. In other words, to write it as a product of numbers that cannot be broken down any further. 24 equals. We have a number of different options here. We can do 24 is 6 times 4, or we can do 24 is 3 times 8. It turns out not to matter as long as you don't make any arithmetic errors. So we will use 24 is equal to 4 times 6. The number 4 can be broken down into 2 times 2. The number 6 can be broken down into 2 times 3. 24 is equal to 2 times 2 times 2 times 3. And notice that the 2's cannot be broken down any further, and 3 cannot be broken down any further. When we write a number as a product of primes, we usually write the primes in increasing order so that it's easy to compare answers. The greatest common factor of two numbers is a number that is a factor of both numbers. A factor of a number is just one of the numbers that can show up in a factorization. Example, find the greatest common factor of 12 and 18. In order to do this, we need to find all the factors of 12 and all the factors of 18. So we'll start with 12. 12 can be written as 1 times 12, 2 times 6, or 3 times 4. The number 18 can be written as 1 times 18, 2 times 9, or 3 times 6. So all the factors of 12 are 1, 2, 3, 4, 6, and 12, and all the factors of 18 are 1, 2, 3, 6, 9, and 18. By comparing both lists, we see that the number 6 appears in both lists, and it is the largest number to appear in both lists. The GCF, the greatest common factor, of 12 and 18 is 6. Section 2.13, Estimating Calculations. When we estimate a calculation, we round one or both of the numbers before performing the calculation. The point of this is to give us numbers that are easier to work with that are close to the correct answer. Example, estimate 31 times 19. 31 times 19 is approximately equal to, we're going to change these numbers to make them easier to work with while keeping the values close. 31 is really close to 30, and 19 is really close to 20. So 31 times 19 is about 30 times 20, which is 600. Sometimes calculations are open to multiple estimates, and the choice of the estimate you use depends on how close you need the answer to be and how easy the calculations are. Example, estimate 209 times 12. One way we can estimate this is 209 is about 200, and 12 is about 10, so the product is about 2,000. We could also have done 209 times 12 is about 209 times 10 by changing only one of the numbers, which is 2090. Both of these estimates are valid, and the one that you use just depends on whether you see an easier multiplication or not. An example of a calculation that might be harder to do would be 209 times 12 is approximately 210 times 12. If you can't do 21 times 12 in your head, then this is not a useful estimate.